I'm John Strum, and this is RealTalk MS. It's November 15th, and we have a lot to talk about. Last week, I was in Dallas, Texas, attending the National MS Society's 2022 Leadership Conference. And a highlight of the conference for me was the opportunity to record this episode of RealTalk MS in front of a live audience. After producing over 270 episodes of the podcast, this was the very first time that I recorded an episode with anyone else in the room. I was really fortunate to have two fantastic guests and a great group of folks in the audience. So in a moment, you'll be taken back to this past Friday, November 11th, for a live episode of RealTalk MS. Today we're coming to you from the National MS Society's 2022 Leadership Conference in Dallas, Texas. And the theme of this year's conference is A Cure is Everything. And I think that pretty much captures what's on the mind of every attendee here and every single person who's part of the MS movement. Over the past couple of days, we've met some of the remarkable leaders in the MS movement. We've learned about some of the amazing research being conducted by MS Society-funded fellows. And I even had an opportunity to talk about the power of storytelling. One of the things we often talk about on this podcast is resilience. It's a quality that people affected by MS quickly learn to develop or build upon. And my first guest today represents what, in my opinion, resilience is all about. Lori Turley was diagnosed with MS in 2021. And when MS caused Lori to end her 21-year career in education, she quickly pivoted, connecting with the National MS Society and involving herself in both fundraising and advocacy. Keep in mind that Lori was diagnosed less than 2 years ago. Let me share a little of what she's been up to since then. Lori's become a member of the Walk MS DFW Planning Committee. And by the way, Lori's Walk MS team placed first in fundraising at this year's Walk MS DFW event. Lori joined the Society's Texas Government Relations Advisory Committee. She's met with Senator John Cornyn's office and Representative Pat Fallon's office. Her letter to the editor was published in the Dallas Morning News, and I'd like to take a minute to share it with you. February 2021 was the worst month of my life. Over the course of 5 days, I progressed from double vision to losing spatial reasoning while driving and to walking into walls at work. I went to the emergency room at UT Southwestern Medical Center, where a kind doctor with a white coat and cowboy boots patted my knee and said, "Hun, I think you have MS." After 3 days, I was discharged with a cane and a pencil eraser-sized lesion in my brain. Since that time, I've battled to regain my health, attending driving school, cognitive therapy, and physical therapy twice a week. The drug I take is designed to prevent future attacks. When it was approved by the Federal Drug Administration in 2017, the cost for twice-yearly infusions was $65,000. My bill last year for 2 IV bags of this medicine was over $300,000. I'm fortunate because I have decent insurance, but I can't help thinking about the people who aren't as fortunate as I am. Something must be done to lower prescription drug prices in this country. I serve as a volunteer with the National MS Society to try to advocate for lower drug costs. We need constituents to contact Senators Ted Cruz and John Cornyn and urge them to act now regarding this issue. Lori Turley, Rockwall, Texas. Lori's made it a point to attend MS Awareness Nights with the Texas Rangers and Dallas Stars, and she's attended the MS Society's On the Move luncheon in Dallas. I think all of that represents an amazing example of resilience. Welcome to the podcast, Lori.
Thank you so much.
So take us back to February 2021 for a moment. What was it that led to your diagnosis?
Actually, 2 years prior, I started having a little numbness and tingling in my feet, had some back issues and eye issues. So I actually visited a neurologist in 2019. And after doing testing and running scans, he said, I think you're just really anxious about your health. So I kind of had that playing in my brain when I had the attack in February of 2021. And I'm not blaming him. I just think that with MS, there's so much unknown about that prodromal phase. And so, maybe I was in that, maybe I wasn't, but I knew that my body felt different. And so in February of 2021, the first thing was a really bad headache. The next day it was double vision. A couple days later, like I said in the article, I was walking into walls at work. And I knew that something was really, really wrong. But I ignored it for 5 days. And I would not recommend that to anyone. But I kept thinking, okay, maybe I am just being anxious about my health. Maybe I just need to press on. And finally, by day 5, I called my husband and I said, you've got to take me to the ER. I said, but wait, I need to finish my workday first. So we went to the hospital. Excuse me. We went to the hospital after I finished the workday. And then the diagnosis came pretty quickly after that.
And what kinds of things went through your mind after you got your diagnosis?
It explained a lot. It made me think back to that 2 years prior, and I tell all of my friends now, don't ignore your body. Try to get a second opinion if you can. I don't know if that would have helped me in 2019, but I feel like I just really want to tell people, your body and when you're off. And I didn't have time to be anxious or attention seeking about my health. And so I would just say, listen to your body. When something is off.
And judging from the time frame, it seems like it didn't take long before you decided you were going to move on from the workforce.
Yeah, so I was off work for about 8 weeks, and I was getting really antsy. I was watching a lot of Aaron Boster YouTube trying to figure out what this disease was. And my friend Jenny actually suggested to me, she knew that I needed something to do because I was really struggling. I hated being in the house and on the couch, but I was still recovering. And she said, why don't you try to join Walk MS? Why don't you do a team? And I said, I don't know. And so she encouraged me a couple of times to do it. And I did it. And we did a virtual walk in my neighborhood, and 125 friends and family showed up. And that was the start of this incredible journey with the society. The next thing that happened in September of last year, I actually got to meet I call her my MS Society bestie, Jackie Rakowski. I finished driving school, so I was able to drive at that point, about 6 months after my diagnosis. And I drove 24 miles to the MS Society, and I volunteered with Jackie. And they were moving offices, and so I started helping her pack. And after about an hour, I was shaking and sweating. I said, Jackie, I can't do this. I was like, I knew right then that, working for me was out of the question. So I kind of jumped out of order there, but I did end up having to retire. I'm on disability. But I feel like with the society, Jackie was so understanding, and so she really understood me, and that I couldn't do everything I wanted to do was okay. I showed up, I tried. And that was a huge boost for me because, going from working all those years, and then you look up and you say, okay, you look in the mirror and you say, I can't do this anymore. What do I do? And I'm not ready to give up. I'm not ready to lay down and just let this thing beat me. I feel like I have a lot to give, and I'm not done yet.
And it seems the areas you focused on were fundraising through Walk MS and also advocacy. What is it about advocacy that resonates with you?
Oh, so much of it. I think for me, I love to learn. So a lot of it was, attending my first virtual public policy conference with you. And I was really drawn by John King being there and his story. So that's really why I attended initially. And then as I learned more in the conference, I thought, well, I want to apply to be an MS activist, and got to interview with LB and Simone Nichols-Seeger. And they just made me feel, everybody at the society has made me feel so welcome and has made me want to learn more. And so through learning more and our training in DC, it really opened my eyes to the plight of other people who aren't as fortunate as me. Like I said in my letter to the editor, we have decent insurance. I'm able to pay, my yearly out of pocket. It's not cheap, but we can do it. But what if I was a single mom, or what about all the other, moms and dads out there who are working to raise their family and they're forced with, putting food on the table or paying for their drug. It's just, to me, it's incomprehensible that you would have to choose your drug or possible brain damage because of money. To me, it's just not right.
I hope you keep saying that until we don't have to say it anymore. It's quite possible that someone who's recently been diagnosed with MS is going to be listening to this conversation. What would you say to them?
That's a great question. I think for me, I want to be real and I want to say it's not easy. There are days when I can't get out of bed, but on the days I can, I want to hit the ground running and I'm going to do my part to make sure that my kids or any other future kids, don't have to worry about this disease. I talked to my doctor and just attending this conference, I truly believe that we will find a cure for MS in my lifetime. And so to that person, this may not be your thing, but don't lose hope. Don't lay down. You are capable of so much. Just listen to your body. Yes, you have to submit to it at times, but on the days you feel good, you still have a lot of value and a lot that you can give in this mission to end MS.
Well, Lori, it's very clear to me that you're not shy about going all in when it comes to the MS movement. So what's next for you?
Actually, someone just asked me to be on a different committee out in the lobby. And it's flattering. It really is. I don't know if I can do it. For me, it's just pushing to raise more money, pushing to make sure that we're getting the policy asks that the MS Society wants, and then just making connections. I've met so many great people. I'm telling you, there hasn't been one person in the society this weekend at this conference that hasn't been so just kind and friendly and listen. And, we're all in this together and we all have a different story, but we are the same. We are all in this to, cure MS. I mean, I really believe that it's going to happen. And I have hope. The MS Society has given me that hope.
Well, Lori Turley, I want to thank you for everything that you do to impact public policy to make access to medications easier and more affordable for everyone. I want to thank you for the fundraising you do to bring us closer to a cure. And I want to thank you for talking with me today.
Thank you for having me.
We're going to switch gears from fundraising and advocacy to research. While the Leadership Conference is going on here in Dallas, so is the Tyson Fellows Conference. And that is an opportunity for the MS Society funded research fellows to come together, to network, to share thoughts and ideas, and to update the rest of us on some of the really interesting research they're working on. One of those fellows is here with me today. My guest is Dr. Brad Zuchero. Brad is a National MS Society Harry Weaver Research Fellow at Stanford University, where he's led research on the actual mechanism that allows our brain to produce myelin. Welcome to the podcast, Brad.
Thanks. Great to be here.
Before we get into the work you're involved in, can you tell us how you found yourself focusing on MS research?
So I come from a very different scientific background than MS or even neuroscience research. I'm originally a cell biologist, so I cut my teeth in my PhD trying to understand how cells in our body change shape and move. So how do cells during development move? How do our immune cells crawl around to chase bacteria or viruses? So I don't actually have a personal connection to MS. At least I didn't until I started coming to these meetings and meeting so many patients and patient advocates. So when it was time for my postdoc, so after my PhD, I was transitioning and I wanted to go into neuroscience. I knew that, but I didn't know what I wanted to work on. And I kept asking people, who's a good person to work for? And I kept getting advice to go check out this guy named Ben Barris, who is a luminary, just an absolutely amazing scientist, mentor, and advocate for women and underrepresented minorities in science. So this is a truly astounding human being. He passed about 3 or 4 years ago now. But he studied glia. He put glia, so all the cells that aren't neurons in our nervous system, he really put them on the scientific map. And so I didn't know anything about glia. I talked to him and he said, Brad, with your background, looking at how cells change shape and move, you really should think about working on oligodendrocytes, the cells that make myelin in the brain, because they undergo very, very dramatic cell morphology changes, in order to build myelin sheaths. So I took some looks at some papers and I was totally hooked. I think this was just the most astonishing cell biology transformation for these cells to be able to reach out arms, sort of like, octopuses reaching out many tentacles, each of these tentacles finding axons. Nobody on the podcast can see my gesticulation, but I promise you I'm gesticulating, to find these axons, wrap around them to make insulating myelin sheaths. And so that's been my passion. I've been working on this now since, early, say 2020 or 2010, 2011 as a postdoc. And then more recently transitioning to start my own lab at Stanford, all thanks to the MS Society's support. I'll say that again and again.
As we all heard yesterday at the conference when we talked about the work the society is really focused on right now, it's that Pathways to Cures initiative, this global effort to stop MS progression, restore lost function, and end MS forever. We all know MS is a demyelinating disease, and when we talk about restoring lost function, we're talking about myelin repair or remyelination. And it's hard to think about remyelination without a clear understanding of how myelin is formed and what gets in the way of forming myelin. So with that introduction, can you walk us through your research a little bit?
Absolutely, happy to. So let's go back to my little analogy here of oligodendrocyte who's trying to extend its fingertips or its tentacles to find axons and wrap around them. How does that actually happen? And so during my postdoc, I was following up on the work that I did in my graduate work where, saying I worked on how cells crawl and move. And so cells crawl and move around and change their shapes by building kind of a scaffold of proteins inside of them called the actin cytoskeleton. Cyto, cell, skeleton. So a cellular skeleton. And a lot of the work that I worked on in my postdoc was looking at roles of how the oligodendrocyte builds and remodels the scaffold at cytoskeleton to drive myelination. I think this is still a really interesting question. And that's something that we're very interested in working on in my lab still. However, what I want to say is, a lot of times we're down in the trenches, working, thinking so hard about this one thing. And what actually really helps is to just step back out of the trench. This happens a lot when I go to conferences. So soon after starting my lab, 2017 or 2018, I was at a conference. I took a step back and I said, you know what? The real question that we need to figure out for understanding how myelin is built and how we could promote its regeneration is to understand how these cells build so much cellular membrane. Okay, so cellular membrane, every cell is surrounded by a membrane. It's made of lipids or fat. Okay, and oligodendrocytes, what's so special about them, what's so special about myelin, is that it is an extraordinary amount of fat or cell membrane that is wrapped many times around axons. So picture in your kitchen the roll of paper towels. That central cardboard tube is the neuron's axon, and then all of those sheets of paper towel around that, that's the membrane or the fat from the oligodendrocyte that has been wrapped around. And that structure is critical for myelin to have its function, to be an electrical insulator. Okay, so coming back to this sort of breakthrough idea, I said, you know what? This is the question. How do oligodendrocytes add all this membrane or all this fat in the right place to make myelin and then remodel myelin? And why does that not happen in MS? And so that's where my research has been able to pivot over the last couple of years. So I've attracted some really amazing students and postdocs to my lab from very diverse scientific backgrounds. And with the support of the society, I was able to take a jump, and take a sort of do a high risk, high reward kind of experiment, pivot to something that I wasn't working on and try to tackle this. And so that's what we've been doing. We have some really exciting data. We just published Nature Communications on kind of the first step forward on understanding how oligodendrocytes add the new membrane in order to generate myelin. And the mechanism we uncovered, we're actually now looking in human MS tissues, samples, some of the data that people have been generating. And there's some really intriguing links there that this process we've identified maybe dysregulated in MS. And so, can we flip the switch to turn this back on to promote remyelination? That's where the work is going now.
So moving forward, understanding this mechanism will allow for targeted therapeutics to be able to start that process, restart it, support that process. Do I have that close to right?
I mean, that's absolutely the hope. Just sort of philosophically speaking, breakthroughs in science, I think there's not just one solution or recipe for how that works. A lot of it is just hard work, grinding day after day in the lab, talking to people, getting ideas and working hard towards something. But then there's also, I think, just a lot to be said for just curiosity, a lot to be said for serendipity as well. So, by following our passions in the lab, really trying to understand how something works, a lot of times we come across things that don't make sense. And you're like, wait, and it sort of eats at you for a while. But that's where the major breakthroughs, the things that are unexpected, come from. For example, just in the spirit of supporting curiosity-driven research, CRISPR. Everyone knows about CRISPR now, right? This was not something that someone sat down and said, we're going to study this. We're going to try to figure this out for human health. It was just, this is some weird thing that bacteria do. We're very interested. And so I think, the same can be said for, in our experience in the lab, driving towards this goal while also keeping an open mind, doing curiosity-driven research, and, really just trying to look out for things that don't make sense, things that could be followed up later that might lead to the next breakthrough. So I think, in general, we got to work hard, and we also have to keep open minds and stay curious.
I was about to ask you what happens next, but I think you just perfectly described what happens next.
I hope so. I mean, what happens next is always sort of, a branching path. So I think a lot of the discoveries that are most exciting, it doesn't just take you to one next thing. It opens a door and you walk into this hallway and now there's 20 more doors. And that's what's so fun for a scientist, that there's so many things to figure out. It's, really, I think coming to a conference like this, talking to physicians, talking to patients as well, that helps us select which of these doors is going to be the one that leads us to the cure, rather than just, down some interesting tangent. So it's good to stay focused.
Once Brad and I finished our conversation, I opened it up to questions from the audience. Since we didn't have microphones out in the audience, you'll hear either Brad or me repeat each of the questions that our audience members asked. Okay, so the question was, what causes fatigue in MS?
I am not a doctor. I'm a cell biologist. We could get some people over here that could answer that question.
Absolutely.
Yeah,
absolutely.
I want to know the answer to that too, but for me, the answer is a 2-year-old and a 7-year-old.
The cells that you're talking about, they're the ones that create myelin.
So the question is it the cells that make myelin that are attacked in MS? Yes. So, the oligodendrocytes or the myelin sheaths are being attacked by immune cells. And the follow-up question, I think this is a really, really interesting question, an insightful question. So maybe some people might say chicken and egg. Is it the myelin that gets attacked that leads to, say, death of the oligodendrocyte, the cell? Is it attack of the oligodendrocyte that leads to degeneration of the myelin? And to be honest with you, we don't have a clear answer on that. It's very interesting. And, a lot of this comes down to the models that we use to study MS. Studying it in humans is very difficult. We in my lab, we make use of mouse models and we purify oligodendrocytes out so we can have these cells in a dish and study them directly. A lot of the models that we use to study MS are not perfect yet. So we have models where we just go in with a toxin and kill the oligodendrocytes in a mouse's brain. That might not accurately reflect how MS works. So I think this is a very important open question. And it's important because if oligodendrocytes aren't actually dying, then there's the potential that could be a novel therapeutic target to promote remyelination. How do we coax those cells to make myelin again? So the question is, am I studying, or is my lab studying, the relationship between Epstein-Barr and MS? Not directly. I think this is so interesting. My lab was able to contribute to this landmark paper that came out of Stanford this year showing the link between EBV and MS, and really got into the mechanistic details. We had no intellectual contribution to that paper. It's a beautiful work. We gave them some oligodendrocyte cells. And so, happy to be listed on that paper. It's just a beautiful work. And it's something that I've been thinking about. How could we leverage what we're really good at to get more into that mechanism? But it's not something we're directly working on yet, but super exciting.
I'll just tack on to that answer that although Brad's lab isn't directly involved, there are an awful lot of folks who are looking at that relationship between Epstein-Barr virus and MS. We can expect to see clinical trials. There are a couple already underway looking at therapies that can go into the B cells in your immune system, find the Epstein-Barr virus that's living in them, and knock it out, which will be very interesting. So those clinical trials are already underway, and we can expect to see more.
Yeah, so this is a question about, after myelin's been gone for a while, the neurons degenerate. What are we doing about that? How can we figure that out? Actually, this is, it maybe shouldn't be a surprise, but it came as a surprise to the scientific community that one of the roles of myelin in our brain is not just to act as an insulator for rapid nerve signaling, but it's also to support the neuron underneath. This wasn't really a surprise for me. So like I said, I trained with a guy who studied glia, put glia on the map. We think neurons are pretty wimpy compared to glia. Glia do all these really interesting things. And so there's been studies now in the past couple of years that there are specific functions of myelin to protect, metabolically support the neurons, keep them happy. And so we actually have a study in my lab. It's on bioarchives right now as a preprint. Hopefully it'll be published in the near future, identifying one more novel role of myelinating glial cells in directly promoting the electrical activity of neurons. And so I think there's still a lot we don't know about what oligodendrocytes and myelin is doing to the underlying neurons. So, fundamental roles that they, you might think, a neuron should be able to be electrically active on its own. But that doesn't seem to be the case, at least in some neuron types. So I think, this is kind of the direction that the field is moving. Let's figure out what exactly oligodendrocytes are doing to the neurons. What functions do the neurons require oligodendrocyte signaling for? If we can figure that out, maybe we can directly drug those neuronal targets and keep the neurons happy, even in the temporary absence of myelin. I think it's a great question. I think it's super, super important because, as important and exciting as glia are, you can't do anything without neurons. They're the electrical conduits of all the information. So, great question. Yeah, so like twofold questions. One, how does a lesion fix itself or resolve sort of, from the cell biologist's perspective? And how do manipulations, chiropractic manipulations or physical things, how could that potentially promote that repair? Yeah, I think, I operate very far away from the patient side. I'm thinking about how oligodendrocytes do this in a mouse model, for instance, and in the human as well. Your question reminded me of this beautiful talk I saw yesterday from Danny Reich, Professor Danny Reich from the NIH, who's a Silver Lowry Award winner this year and gave kind of the keynote yesterday in our fellows meetings. So he showed this beautiful movie of a longitudinal MRI of a patient over, I think, about a decade. So coming in every month and doing MRI imaging of the brain, using the best and fanciest MRI machines that they have. And you can watch over time these lesions appear and resolve, kind of coming and going, consistent with the lesion starting and then resolving by remyelination. And then over time, this was from quite some time ago when there were fewer disease-modifying therapies, but over time you do see some lesions that appear and then don't resolve. So, from the perspective of a cell biologist, what's happening is that our bodies have a natural capacity to regenerate, but this capacity to regenerate, maybe it doesn't have the resilience that we talked about earlier. And, maybe over time as the disease progresses or with aging, it becomes harder and harder for it to do that remyelination itself. And that's where the need for drugs that promote remyelination come in. How do we continue to harness the body's natural ability to do this and make it do it better? I think that's the question. And to your second point about, physical activity or things like this promoting myelination, there's been really, really, really a lot in the last couple of years, really exciting studies showing that this all started actually with human MRI imaging where people learned how to do a new motor task. And you see if someone learns how to do a new motor task like juggling, playing the piano, you actually have changes in your white matter, so your myelinating tracts in the brain. And now this has been followed up in mouse studies where we can do some mechanistic stuff. And you can see that in response to activity or learning something new or just neuronal activity itself, myelin will form, myelin will remodel. It's a novel form of plasticity in our brains that we're just starting to unlock. So my suspicion is with all these types of, chiropractics or whatever, doing exercise, there could be a real mechanistic link here. You could be directly promoting the formation of new myelin. And I think that's where the field is going to try to understand, is that normally happening? And is that another thing that we could potentially harness to promote repair? Yeah. So the question is about just, how do we choose a good scientific problem, an important scientific problem when we make a discovery and it opens many doors? So, one solution is to recruit a really excited, creative group of people that have diverse interests and backgrounds that can open up multiple doors. People can follow their passions. I really try to encourage, it's sort of, almost like an artist collective kind of feel in the lab where people have their own interests. I'm there to sort of, to steer the ship, but I don't want to say, you have to work on this thing. You go down this door. I let people explore. I think that creates a lab environment where people are open and curious and stay motivated when doors lead into brick walls, which happens very, very often in science. So I think, the idea is, can we figure out, we call this, what's the hypothesis killing experiment? Or like my mentor, Ben, would say, go for the jugular of this question. If you see a door that looks interesting, you don't want to wander into a door and go down a rabbit hole for, a year and waste all that time. You want to figure out, what is the one experiment I could do that kills my favorite hypothesis? The idea that I think is the best idea ever, how can I disprove that? So rather than trying to figure out all the things that's going to pad my ego and make it seem like it works, how do we actually test it for real and know, is this the direction to go or not? That's the challenge. But that's what we are always working towards, So I tell everyone in my lab, we're not here to get high-profile papers and flashy journals. We're not here for fame or glory. We're here to understand how the universe works, how the body works, so that we can actually do something meaningful.
Our questioner is asking about recent breakthroughs in MS research.
Yeah, so I mentioned this talk from Daniel Reich at the NIH yesterday. He had this just really beautiful story combining all the most amazing modern technology. So technology is great because that's how we make new discoveries. And so he has been able to combine really high power MRI with mouse models of MS and using this new technology called single cell RNA-seq, where you can go in, break apart all the cells in a mouse's brain and look at them individually and see which genes they turn on. So you can figure out what are all the different cell types and what are they doing differently in an MS model than what they're doing normally in a healthy brain. And so there's so many questions that popped out of this. Looking at this, he identified new cell types that he then went back into MS lesions and found evidence for these same exact cell types, showing that the mouse model is really nicely modeling what's happening in the disease. So there are some novel cell types that are doing potentially interesting things. The more we look, the more we realize that there are things that we don't know. And this opens up the possibility for novel therapeutic targets. So that's what I'm going to keep thinking about and hope to find a chance to talk to him too.
So this question is for both Brad and Lori. And if I can paraphrase, our questioner wants to know how you manage the wins and losses that scientists and people living with MS face every day.
It's hard, being at a place like Stanford with just amazingly talented, famous scientists everywhere. I think more often than not, it's like, oh shoot, can I cut it? But then there are good days too, where I look around and say, oh my goodness, look at this. This is an amazing privilege to be able to work with these amazing people in this just, phenomenal environment. One day was the day that I got the email saying, congratulations, you got the Harry Weaver Award from the MS. That was the day I said, okay, I'm good for the day. I'm going to go take a celebratory run. And then get back to work.
The day I started driving again, I was like, yes, but I didn't feel very awesome. My spatial reasoning is still, don't get in a car with me. I'm kind of going to echo what he says, but about my family, my husband and my kids are amazing. They are the ones that prop me up. They y'all know how it is. They see you day in and day out when it's really bad. And when you want to and you can't, you get frustrated. And, if it wasn't for them, there's no way I'd be sitting here.
Well, I want to thank Lori Turley and Dr. Brad Zuchero for joining me today. I'll also thank the National MS Society for making this special episode of RealTalk MS possible. And a very special thanks to this great audience for being a part of today's podcast. I'm John Strum. Thanks for listening. Stay safe and make healthy choices.